Hello, we start our review with the problem find the measure of two angles, one positive and one negative, that are coterminal with the given angle. So the given angle is 119 degrees. Coterminal angle all coterminal angle have the same terminal side, so the difference between them is always 360 degrees. So we can either add 360, 119 plus 360, or we can subtract 360. Both operations will give a coterminal angle. So 119 plus 360 will be 476 degrees, minus 360, so it will be negative 360 minus 119 will be 241 degree. Next problem, find the measure of each marked angle. So we have a triangle, and we know that the sum of the angles of the triangle A plus B plus C is always 180 degrees. So A, B, and C are given through x in terms of x plus 30 plus 210 minus 3x must be equal to 180. So we have here like terms with x. 1 plus 1 minus 3 will be minus 1x, and terms without x. 30 and 210 will be 240 degrees equals to 180. So let us subtract 180 and add x to this equation. So when we add x will appear on the right. When we subtract 180, we will get 60 degrees. So x equals 60 degrees. And the homework, if the question is give the measures of all angles, on the exam you will be asked to find x only. Another variation of the problem with x, find the measure of each marked angle. The lines are parallel, so this angle, let us find the measure of angle A. So the lines are parallel. We have here two complementary angles. They add up to 180. X plus 5 plus 2x minus 26 equals 180 degrees. We solve this equation for x. Again, we have like terms with x, 1 plus 2, 3x. Like terms without x. 5 minus 26 will be minus 21 equals 180. Let us add 21 to this equation, to the left and to the right. 3x equals 180 plus 21. 3x equals 201, and divide by 3. X equals 201 divided by 3. 6 and 67 degrees. So, and the question is, what is the measure of angle A? The angle A is alternative angle with the angle x plus 5. So A is equal x plus 5, or 67 plus 5, 72 degrees. Number 4, sketch an angle theta in standard position such that theta has the least possible positive measure and the point 3 and negative 4 is on the terminal side of theta. Then find the exact values of 6 trigonometric functions. So let us first sketch this angle. It's always very helpful for trigonometric problems. So the point has the x coordinate 3 and y coordinate -4. X is 3, y is -4. So this point lies on terminal side of the angle theta. There can be several angles, or can be positive angle, negative angle. We are interested only in the terminal side and trigonometric functions. Trigonometric functions of all coterminal angles are the same. So we want to find trigonometric functions of this angle. So for trigonometric functions, we need x, y, and r. And r can be found by Pythagorean theorem as x squared plus y squared, and take the square root. So square root of 4 squared, 16, plus 3 squared plus 9, which is 5. So r is 5. Now we can write all the trig function like sine theta is y over r, -4/5. Cosine theta is x over r, 3/5. Of course, it is positive in the fourth quadrant. Tangent theta, y over x, -4/3, and so on. Use trigonometric function values of the quadrantal angles to evaluate sine of 270 plus 7 cosine of 180. So unit circle is the best way to determine trigonometric function values for quadrantal angles. So just locate correctly quadrantal angles. 270 is here. This point on the unit circle, it has coordinates 0 and -1. This is the cosine, this is the second is the sine. 180 degrees is a straight angle. This point has coordinates -1 and 0. So this expression will be equal to sine of 270, the second component, the second coordinate -1, plus 7 times cosine. Cosine of 180 is -1 times -1. -1 minus 7, -8. Find the values of theta in the interval from 0 to 360 that have given function value. Cosine theta is square root of 2 over 2. This is also a problem which is easy to solve using unit circle. On the unit circle, we find the values with the given cosine. Find the point with the x component, square root of 2 over 2. Square root of 2 over 2. Square root of 2 over 2, both positive, so there will be component angles in the first and in the fourth quadrant, and this value of cosine have the angles with the reference angle 45 degrees. The answer we want to have in degrees. So, and it's not -45, but 360 minus 45, 315 degrees, and here 45 degrees. So two angles, 45 degrees and 315 degrees, have this cosine value. Another example, we say of the same kind. This time cosine is equal to -1/2. So negative cosine is on the left from the y-axis. to the left from the y-axis, so we'll, and negative 1/2 is here, so we have two angles. The reference angle 60 degrees, so it is 180 minus 60, 120, and 180 plus 60, 240 degrees. So 120 degrees, 240 degrees. Convert the following degree measure to a radian measure. 225 degrees. So there are two ways to convert. Either you look on the unit circle, 225 is 180 plus 45 is this angle, and you know that it is reference angle pi over 4, so we have 1, 2, 3, 4, 5 pi over 4. Or the second method, you multiply by the factor, so 225. You want to convert to degrees, so it will be, the answer must be with pi, so you multiply by pi and divide by 180. Maybe not so easy, but if you find the common factor, the 225 is 5 times 45 times pi, and 180 is 4 times 45, then it will be the same 5 pi over 4. Find the exact function value cosecant of pi over 3. So first we must represent cosecant in terms of cosine and sine function that we are more familiar with. Cosecant is the reciprocal of sine. So it is 1 over sine pi over 3. Sine of pi over 3 can be found on the unit circle. So pi over 3 or 60 degrees is this angle. Its sine is square root of 3 over 2. So we have 1 divided by square root of 3 over 2, which is the same as 1 multiplied by 2 over square root of 3. And we can rationalize by multiplying by square root of 3 numerator and denominator, 2 square root of 3 over 3. And a similar problem, find the exact value of cosecant of pi over 4. Again, cosecant of pi over 4 is 1 over sine of pi over 4. Sine of pi over 4 is square root of 2 over 2. Reciprocal of square root of 2 over 2 is 2 over square root of 2. Or you can multiply by square root of 2 numerator and denominator. It will be 2 square root of 2 over 2 square root of 2. Determine the equation of the graph, of the given graph. So we need to read from the graph the amplitude. The amplitude is, the graph is not shifted vertically, so the amplitude is just this value, 2. Then sine or cosine. Sine, so this is possibly the sines, and it start from the zero value, from its middle value. I mean the amplitude, so start from 0. And cosine is usually start from minimum or maximum value. So if it starts from minimum, it's negative cosine. If it starts from maximum, it's positive cosine. Then we want to find b. B is 2 pi over p, period. What is the period? The complete cosine wave takes pi units. So we must divide 2 pi by pi and b equals 2. So it is a cosine of 2x. The next one is a sine. The amplitude, there's no vertical shift, so the amplitude is given by this value. So then here is 7 minus 2, 5. 5 sine, then the period. So b is 2 pi divided by period. Period is 1 sine wave. So 2 waves are on the interval pi. So here must be pi over 2. So the period is pi over 2, and we must divide 2 pi by pi over 2, and we get 4. So it is 5 sine 4x. Describe the function y equals 9 minus cosine 2x plus pi over 5. So this is the vertical shift. So amplitude is 1. Then the period, so b equals 2. It means that period p equals 2 pi over b, or 2 pi over 2, period is pi. And horizontal shift or phase shift. So this is the number that is subtracted from x. Pi over 5 is subtracted from 2x. So first let us factor 2. 2x plus pi over 5. When we factor out 2, we'll get x plus pi over 10. So the horizontal shift is negative pi over 10. I will not ask you for the shift on the exam, but you must be able to recognize amplitude and period. So find 5 remaining trigonometric functions. So if you are given secant of theta, so secant of theta equals 7 over 4. So if we have a secant, we have a very convenient formula to start with tangent. Tangent squared theta plus 1 equals secant squared theta. So we can find tangent knowing the quadrant. So what do we know about the quadrant? Sine is negative. It means the quadrant 3 or 4. And secant is 1 over cosine. So cosine is positive. So the quadrant 4. In quadrant 4, cosine is positive and sine is negative. Now we can solve this equation. Let us subtract 1. Tangent squared equals theta equals secant squared theta minus 1. So tangent theta will be equal to square root of secant squared minus 1. And from plus minus, according to the quadrant 4, we choose minus. Now we can substitute, or you can substitute from the very beginning. Tangent is negative square root of secant squared 49 over 16 minus 1. Let us represent 1 as 16 over 16 to get the same denominator. So we have negative square root of 16 in denominator, and in the numerator 49 minus 16 will be 33. So tangent theta equals negative square root of 33 over 4. So I will only ask you for one tangent value, not all the rest. That's why we will stop here.